Assalamualaikum warahmatullahi wabarakatuh. Today I would like to introduce myself. My name is Danish baqry anuar, and I would like to present the introduction, the theory about our lab, which called the design and analysis of car disc brake system. So today I will introduce you to the fundamental working of disc brakes, crucial components in modern vehicle braking system. Disc brakes are designed with a metal disc and commonly refers to as a rotor, which rotates along with the vehicle wheels. Unlike drum brakes, disc brakes use a pair of flat friction line pads that are pressed against the rotating disc to create the necessary braking force. And these pads are held in a component known as the caliper, which straddles the disc. The caliper contains one or more pistons, each fitted with a seal and a dust boot for protection. When the brake pedal is pressed, hydraulic pressure is applied behind the pistons, forcing them outward. This action pushes the pads into direct contact with the disc, creating friction that slows down and eventually stop the vehicle. And it's important to note that when servicing brake discs, both discs on the same axle, either the front or rear, should always be renewed or refinished together. And even if only one disc is damaged or worn, similarly, brake pads should be replaced on both wheels at the same time to ensure balanced braking performance. Lastly, a critical safety precaution when working with brake system is to be aware of brake dust, which may contain harmful substances like asbestos. This dust should never be blown out with compressed air. Instead, appropriate safety measures such as wearing an approved filtering mask should always be taken to protect your health. Thank you. This concludes the introduction of this brakes.
So this is the material properties for rotor disc brake for our group. The material is iron and the Young modulus is 2.11E plus 0.11 Nm square. The Poisson's ratio is 0.291 and the density is 7,870 kg m cube. Coefficient of thermal expansion is 1.2E minus 0.05 k degree. The yield strength is 3.1E plus 0.08 Nm square.
My name is Hanif. Today I will going to present our group about void stress board. In the here and this we can see their design of we are using Katia to design our rotor disc. For the next we can see the maximum void stress 5.28, 5.24, In minimum void mistress is 1.04. In transportation displacement is 274 millimeter. Our factor of safety, we real strength per maximum void miss, and we got 0.6507.
Okay, my name is Wendy Narra, and I will present the discussion for our lab. So from the analysis result, we get that the maximum void mistress is 5.24 E plus 0.11 and m square, while the minimum void mistress stress is 1.04 E plus 0.08 n2. The maximum void mistress observed is larger than the yield strength of the rotor disc material, so the disc will not be safe against the load. The factor of safety that we have calculated is 0.6507. So next, there are a number of factors that can affect the safety factor of a brake. It is include the material of the brake disc, the design of the brake disc, the manufacturing process, and the operating conditions of the brake disc. It is important to select a brake disc that has a safety factor that is appropriate for the intended application. So, for example, a brake disc that is used in a high-performance vehicle will need to have a higher safety factor than a brake disc that is used in a passenger car. Overall, the safety factor of the brake disc is a good measure of its ability to withstand stress before deforming. However, it is important to note that the safety factor is not a guarantee that the brake disc will never deform. Thank you.